Right, question 2 is about forces. It's a whopping 19 marks out of 80, almost a quarter of the paper on this question. So if we're going to cock one up, let's hope it's not this one. We've got a hailstone falling. So that's the weight of the hailstone, that's the air resistance pushing it up. And this is a wind blowing it horizontally to the right. It says calculate the magnitude and direction of the resultant force, right? So we're going to get the resultant horizontal, the resultant vertical, and then square add root to get the total resultant. So the resultant vertical here is 6, take away 4, so that's 2 times 10 to the minus 4 in the downward direction. You can call it minus 2 if you want. I've just stated it's down. There's only one force horizontally, that's 5 to the right. So the magnitude is this squared plus this squared, all square rooted, which comes out as 5.4 times 10 to the minus 4 newtons. The direction, of course, is tan to the minus 1 of the vertical over the horizontal. Okay, so think of this as being 2 down here and 5 across there. We're looking for this angle here, and that's tan to the minus 1 of the vertical over horizontal. Chuck that in your calculator and it comes out as 21.8 degrees. Now if you've carried through the minus 2 here, it'll say minus 21.8 degrees. If you didn't, like I have, you have to state the fact that that's 21.8 degrees below the horizontal. That's that angle there. At a later time the wind has stopped blowing, so there's no horizontal force now. Explain in terms of forces why it will eventually become at terminal velocity. So as the speed increases, the air resistance on it will increase. It'll come to a point where that force due to air resistance equals the force due to gravity. There'll be no resultant force, hence there'll be no acceleration. Hence it's moving at a constant velocity that we call the terminal velocity. Straight out of the book, learn that off by heart. Sorry, none of that was on camera when I said it. Okay, there it is there. Right, on to the next part of this massive question. So we have an experiment to measure the value of gravity. Nice pretty simple setup, electromagnet linked to a switch on a timer. So hit the timer, the electromagnet loses its current and magnetism, drops the ball hits a plate, which then lifts a contact to break the circuit again to stop the timer. Right, so pretty clever, to be fair. And it measures the height here, that obviously we're going to look at in a minute. Alad has told us a very small time delay between the switch being pressed and the ball being released. This is a systematic error, which means it's an error in some of the equipment in the system. The manufacturer states that the time delay is 0.05 seconds. How should Alad account for it? Well, it's not rocket science, it really isn't, right? It's just a one marker. You just take 0.05 seconds off every reading that you get when the ball hits the metal plate. Right, moving on. So he records all of his results, including that taken off the 0.05 in this table here. And it says complete the row for time squared, giving your answers to an appropriate number of sig figs. So they've gone to 2 sig figs everywhere, so we'll just stick with 2 sig figs in that row. Happy 2 marks for that. So just square these numbers in your calculator, round them correctly, put them in. Next question. Here's the relationship then used to find a value for G. So the value of gravity is twice the height divided by the time taken squared. Show how this relationship is taken from an appropriate equation of accelerated motion. Now we call accelerated motion equation our SUVATs. V equals U plus AT, etc. V squared is U squared plus 2AS. Now we want one that's related to height is a distance, so that's S. G is acceleration. T is time. There's no velocities involved in there really at all. So I'm going to pick this one. S equals ut plus a half at squared. And of course initially u is 0 because initially it's at rest. So that bit can just disappear. And I've got s equals a half at squared. Right, now let's swap some stuff in. S is the distance, which we've called h. A is the acceleration due to gravity, so let's call it g. So now it looks like that. So now we're getting there. Bring over the t squared, it'll come over underneath as a divide because it's a multiply there. Bring over the half, it becomes a times by 2, and then you end up with the equation they asked for. Right, so that wasn't too tricky. Then it says, plot the graph of the points in that table on the previous page and draw a line of best fit. So I've done that, 4 marks. Careful, they didn't give you any numbers for the scales, but it was pretty easy to figure out what the numbers were going to be. And then it says, use your graph to determine a value for G. Now don't forget, they told us, excuse me, that G is 2 times h over t squared. H is the vertical axis, t squared is the horizontal axis. When you do vertical over horizontal, you are effectively finding the gradient of that line. So I need to find the gradient of this line and then times it by 2 in this case, because of that 2 there that they gave us earlier. So I picked this point here. So my vertical was 2, my horizontal was 0.41. I should have wrote squared there. I chucked all that in the calculator. Sorry, I didn't need squared there because it's already squared on the axis. Chucked all that in the calculator and I came out with 9.76. Very happy because I know that gravity is 9.81. Discuss to what extent your graph, this graph here, agrees with this equation G equals 2h over t squared. Well, it goes through the origin, which is great. Because it hasn't travelled any distance when t equals 0. It's a straight line graph, or the line of best fit is pretty close to it, indicating that they're directly proportional to each other. And of course the value of G that we've determined from that graph is very close to the actual value of 9.81. What a massive question. Don't forget, if any time you're drawing a graph on an AS Physics P1 paper, you're either finding the gradient of it or the area underneath it every time. So look out for those. Nice one. Goodbye.